It simply says that we have given an untitled connected tree with n nodes labeled from 0 to n minus 1. Edges will be labeled from ai to bi, and there's an edge from ai to bi. I have to find an answer array in which answer for I is every node. Answer for I is the sum of distances between ith node to all the other nodes of that tree. But what I mean by that is, for example, I have to find the answer of 0. So answer of 0 will be the distance from 0 to all the other nodes. Okay, from 0 to 1 the distance is 1, 0 to 3 the distance is 2, 0 to 2 the distance is 1, 0 to 4 the distance is 2, 0 to 5 the distance is 2. So I will take the summation of all the distances from a node 0 to all the other nodes and thus get the answer, which is 8. Same way I will have to perform it for all the children's 1, 2, 3, as in for all the nodes. I have to go and perform the exact same operation. So very naively I can easily say, okay Aryan, I have to go, if I am standing at a node, I have to go and find the distance to all the other nodes. I can simply do one thing. I have to just go and find the distance, right? And distance, simply say, okay, this is the distance. So if I go and ask, okay, for node 2, the distance to all their childrens will be the number of children. Okay, the number of children for node 2 are actually 3. Now again, just make sure I'm telling you that how you can find the answer of 0 in the most naive way. In the most naive way, you can simply go on to all the child. Again, as for 0, you'll go on to its child. Oh, he was the child, and you know that you have only one child, and that one child itself was just here. So you will say, okay, I will simply return a 1. You will go on to your child 2. You will ask your child 2, bro, what is the number, what is the value which you can give me, right? And I know that how many such childs I have with me. I have 4 childs. So let's say if 2 gives me that, okay, for 2, if he will take use of his child, 2 will ask all its child, and all of them are just the leaf nodes. 2 will ask his child, okay, they will say, okay, I am 1, I am 1, I am 1. So 2 will say, okay, for the 3 nodes which are below me, they are at a distance of 1. So technically the answer for 2, again, when I mean my answer, I mean just simply saying how many, the distance to all the nodes in the children of 2, what is the distance like? He will say the distance is 3. Now you have to find, taking node 0, you can only communicate with the child. You can only communicate with the child which is 2. For node 0, you have to find what should be the distance. What should be the distance? So you will simply go and ask, bro, what distance I should pass? I know one thing for sure, that okay, he gave me 3. He gave me 3 considering he gave me this row. Again, let's change a color and say that he gave me, again, I will just erase everything. 2 gave me this one edge and this one edge. That is what 3 means here. But I wanted this entire edges, this entire edges, this entire edge, and also an edge from 2 to 1. So what do you think? What is the extra contribution I am actually adding right now? I am adding, again, in this, if you see this entire edge, in this edge is already I have pasted here. So other edge will be remaining this. And same way, this edge is already here, so other edge will be this. This is a new edge for sure, and this edge itself already here, so this is a new edge. So you can easily see that for I added how many extra edges? I added 4 extra edges. Remaining 3 was already there. And how was that 4 came in picture? Because of the number of children I have. So I had 4 children, so I added a 4 for all those childrens. So you realized I will keep track of, okay, for every node I will keep track how much I'm getting from my children, and to pass into my parent I will need to also keep track whatsoever answer I got from my child. Again, this answer is only from my children. So whatever answer I got from my child, take that answer, and also please make sure to add the count of all the childrens, which is 4, and thus I got a 1 from here, 7 from here, answer is 8. but make sure that you did this operation on one of your node, on one of your node. Again, you will have to repeat the same process for all the nodes, which means 1, which means 2, which means 3, which means 4, which means 5. So this, as you can simply say, it's a simple DFS call. Again, it is actually an optimized DFS call because you are using the child itself to get the answer. You are using, okay, for at a node 2, you are only using the, sorry, at a node 0, you are only using the node 2 to get the answer for node 0. So you will repeat this O of n process. It's a simple DFS call. You will repeat this for all the nodes 0, 1, 2. So it will be O of n square. Can we improvise it as a question? Can we improvise it? Maybe, maybe not. We can actually, again, make sure the thing which I told you, that to find the answer for node 0, how I found the answer, although I will show you with the dry run again later on, but make sure that can be a starting point. And maybe, again, that was a starting point for me. Maybe I can actually end up reducing some calls and maybe taking the help from my children itself. So I will take this example. As in this case itself, I was, if you remembered, I was taking help from my 2 to just get the answer for 0. And I was taking help how I was saying, okay, for 2, as it can only see his child, so he can go on to his child, and then whatsoever answer he has got, I will add the number of children in its subtree. But Aryan, again, like, it seems okay, you are taking help from a child, that is okay, but with that also you will only be able to find the answer for your root node. Now, for the folks who still haven't understood how I am taking the help from my child, let's see this very easy diagram. Imagine that you have 2 separate subtrees or separate trees. Let's say I had a tree A, I had a tree M. Aryan Mittal, okay, tree A and M. Now, if you want to go and find the answer for a tree A, answer, again, make sure मकसद नहीं भूलना है, your aim is to find the answer. Answer for tree A will be the distance to all the nodes. As you can simply see, for this node 1, 2, 3 and 4. Sorry, 1, 2, 1 and 2. The distance is 6. And I have to take a summation. And the same way, 1, 1, 2, 1 and 2. Distance is 7. Now imagine that separately you have answers for A and M. Imagine that these 2 trees are separate enough. But now, as you know, that you have to take use of your child. Again, I am just explaining this very same fact I explained to get the answer for your root node. For one of them, how I am building my answer. I'm just showing you the actual dry run for the folks who didn't understand that. So if you understood it, please skip this part and then go on to the next part. Now I realize that now I am saying that this tree M is actually a subtree, or basically a child of my parent A. So M Mittal is actually a child of my A, Aryan. Now if that is the case, so I have added this one edge. This one edge is the child. Now I have to go and find the answer for A of the root node. I know that it's one of the child is this one. Now another child added is this one. Now I already know the answer for this child, which is 7. I already don't know the answer of existing child of A, which was 6. But I added something extra. I added one edge. Because of adding one edge, what will be the implications? Because of this adding one edge, I will actually be increasing the distance to all these nodes by 1. Because you will see that earlier, okay, all these were there. Now I am saying I have made it an edge from A to M. So M is a child of A. Now for sure all these contributions of my child should be added in my answer A. Okay, I can simply add the answer. I can simply add all of these contributions of answer in my A directly. But is it enough? Is it enough? Which means, can I say that the answer of A was existing answer of A, which is 6, and the new answer of M, which is 7. Can I simply say that? Can you easily see that you never counted the contribution of this edge? And for sure, as this edge is added, every of the child nodes of M, it became one distance away from A. So I realized that, okay, because of adding one edge between A and M, all the children of M, it became one more distance away from A. And how many such nodes became one more distance away from A? These many number of nodes. 1, 2, 3, 4, 5, 6. 6 nodes became one more distance away from A. So now, if I know, okay, 6 is this child, 6 is these distances, these 6 is, if I just show in the different color, 6, okay, 6 is these distances, this and this. 7 is the distances inside this, which I already had computed. Because of adding one child, all these became one more distance away. So I realized, okay, to find the answer of A, when a child M is added to A, I can easily say the answer of existing A, which means existing child of A. Now the child which was M, which is newly added, which is in this case M, and this count of M is because of the link, because of the edge between A and M, this is the new distance added for all the children of M from A, and that will be the actual answer of your A as soon as your child M is added. Again, this is, I'm only saying there is a correct answer of A. This will not still say the correct answer of M, because in this case I'm considering M is a child of A. Right? M is still a child of A, and this proves the thing which I showed you in the very beginning also. Just in one DFS call, how will you find the answer for your root node which is 0? And same way you will repeat the same process to find the answer for your 1, 2, and so on and so forth. But Aryan, you did so much of stuff just to find this answer for 1. Still the complexity will be O of n square? Yeah, it will still be O of n square. So can we use something? So far we realized that, okay, we can use these links somehow, and we also realized that I have to keep track of the count of a subtree. What all things I need to keep track of? I will be finding my answer, general answer for my child, but for my child, the answer which I am trying to find out, the answer I am finding, it will be an incomplete answer. Only the answer of my root node will actually be, or I should say parent node should be a correct answer. In this case itself, if I go back and ask you, although I was computing the answer for this also, but only the answer of my 0 will be the complete answer or the correct answer. For all of them, it will be a partial answer, and when I mean partial answer, which means I only am considering the child nodes of this specific 2. Which means I am considering this as a root node and then this as a child. That is it. So when the entire tree is covered by a specific node, then that will be my root node, and that is going to be my answer for him. So I realized that only the answer, again make sure answer is being built, but this answer for M is incorrect. Only the answer for A will be correct, which is the extreme root or the parent node. And same way I will be needing the help of count of number of nodes in a subtree, because we know it's a tree. So as soon as I will add an edge from my A to M, I will also should be knowing the count of number of nodes in a subtree. How I can do that? I can simply find by simply doing a DFS. So I will simply go, as soon as I got a node, it's a leaf node, okay, put the count as 0, put the count as 1. By default, I can keep the track of count as 1. As I go on to my parent, okay, parent will ask all its children, what are all your counts? Okay, I will get the summation of the counts of my children. I will add a +1 to take the entire count of my subtree, and then I will return that to my parent. So he will return a 1, he will return a 4, and then to find the answer at me as a node, I will ask all my children, take the summation of them, which is 5, add a 1 for my contribution, and I will get as 3 plus 1, 4 plus 1, 5. 5 is saying I have 5 nodes in my subtree. It is just the same way saying count the number of elements in a subtree. Okay, count you have found, and with the help of this count you can simply find your answer, temporary answer. Only again, while finding your temporary answer, the answer built for the root node will be the final answer. But still, Aryan, I still did not reach to a conclusion. Although you showed me that, okay, answer for specific node will be the answer for its child plus the count of the number of children. The same way as you're doing for this, answer for A is answer for its child, plus, as you can see, answer for A is answer for its child, which is this one, answer for its child, which is M, and the count of number of nodes in its child because of the adding of edge. So I know one thing for sure, that for a specific node, the answer will look like answer for its child and plus the count of number of nodes in its child. And the same way for node 0 also, answer for its child plus the count of number of nodes for its child. And the same way I have done a simple dry run to let you know that it is actually working for the node. Now, still Aryan, you showed everything correctly for a specific node, and the answer which you are building right now will be for a specific node, which is a root node. As you already said that the answer which I am building, because this answer is also being built, this answer 2 is also being built, but this is an incomplete answer. This is the answer only for its childs. But if you remember, I have to consider all the nodes as the root node. I have only found the answer for my parent, that's it. And the parent, when I say parent, I mean only the root node. So somehow I have to take, because now somehow my child, again, I have found the answer for my parent, I have all the things sorted. Now I have to find the answer for my child. So the child will now take the use of its parent. Now this child, which is M, will now take the use of its parent, which is A. If you remembered, A was the root node. Again, I am now going on from, again, if you remember, while building the answer, I was using this answer, okay, I was using these two to compute this answer. Then I was using these two to compute this answer. And then this answer was the final answer. Now I have got the final answer for my parent, which is the root node. Now I will use this final answer to compute this answer and this answer, which will be the correct answer. Then I will use this answer, final answer, again, this will be a final answer. I will use this answer to compute the answer for child. So you see, while finding the answer for the root node, I went on from very leaf nodes to up. But while I will be finding the answer for my child nodes, I will take in consideration the answer for my root node, and I will take the help from my root node as in the parent, and parent will start from the root node itself and then go on to my child. Okay, everything is sorted now. Now I know for finding the answer of M, I have to take the help of my parent, because parent contains the correct value. Because parent can have other leaf nodes also. I just have to take in consideration M into account. Now, very simple fact. I will ask you that your parent A has already taken you. Again, imagine you as a child and A as a parent. So your parent A has already taken you in consideration and got his answer. So he got his answer as 19. When your parent A took in consideration you and also added the M. Again, adding this M was the count of M is the number of children of M. It is because he added an edge from A to M, and this is the count which he added. Now you have to simply go and find the answer for M. So simply you can easily see that if you have to find the answer for your M, the additions which he did, which is the count of M, it simply says, okay, 1 again for this node, 1 again for this node, 1 again for this edge, 1 again for this edge, 1 again for this edge. So for all the edges inside this, again, for all the distances, if I just erase all these separate ones, so for all the distances inside this, again, for this one distance, he added one edge, which is one count. For this one edge, he added one more distance. For this one edge, he added one more distance. For this one edge, again, up to this node, he added one more distance. For this edge, he added one more distance. So that is the reason I added a count of M. so as to get the contribution of these blue edges inside the children of M. But now I am saying that I will only use, now my actual root node is M itself. So what is the point of getting the contribution of my children itself? I am at M. I already have the contribution. Okay, if I am at M, I should actually not use these contributions which A added to me, because I am now at M, standing at M. But you will say, Aryan, then what about the reverse contributions? Which means, okay, A added an edge to M to get to know about the children of M. A added an edge to M to get to know about the children of M and how many children of M had. But now you are saying that you want to technically add an edge from A to M, which means you will again, firstly, you removed an edge from A to M, because A to M edge, this A to M edge represent that I will add in contribution of the children of M, but you removed it because you know that you are standing at M itself, so you don't want the contributions of this specific edge. But vice versa, you want the contribution from M to A, which means how many children does this had, does my parent had. So I have to, instead, basically I will remove the contribution of M, count of M, which is the children of M, but in the reverse manner, I will add the contribution of the other remaining nodes. How many number of nodes are remaining? So what I did was, again, make sure, right now it might seem like, okay, Aryan, it is the same thing you are doing now, but make sure A was a parent, which means A had the property. This was your A, this was your M. So M childrens are these. So you technically did what? You had the answer for A. And answer for A actually added this contribution, which is the count of child. So as you are now at M itself, which is a child, so you will simply remove the count of child, the contribution of your child, which means this edge, when A was adding an edge to M, so A added, okay, how many? A added how many edge? So A would have added 1, 2, 3, 4. A would have added 4. And said, okay, because I have the children of M will be actually 4 distance. I will add the new contribution of 4 for the children of 4. So now, as to find the answer for M, I will remove the contribution of my children itself. I'll remove the contribution. Instead, I should now add the contribution, because I know from this child, when A was considering, he would have never considered this entire stuff adding. He only considered me because I was different than him. But now when I am at child, I have to consider the contribution that, okay, how many such nodes are in the remaining part of my parent. So I know if I have the count of child number of nodes in me, then the other, I know in total I have n nodes. So the other number of nodes will be n minus count of child. And that I will add for my parent, because this will be the contribution. Again, considering right now I am thinking about my child, I removed whatsoever my parent previously added for me, and now I added something for my parent, because I have to go to my parent now. So this is what I added for my parent. This is specifically, again, you cannot simply say I will simply remove both of them. No, both of them will be a different count. So your child can have let's say 3 nodes. Your parent can have, let's say, like 8, 9 nodes. So this is your answer of your child. This will be your answer of your child. And that's how you simply get the answer for all your childs. Make sure how the answer is being built. Firstly, I will repeat one last time how the answer was being built was that while getting the answer for your root node, you went on to leaf nodes, get the answer, leaf node, get the answer. You were also getting the count also from your leaf nodes, or basically from your child nodes. From here also you got the answer, and then answer plus your count gave you the final answer of your root node. Now when you have, again, you realize that your root node was actually the answer for just one node, but now you have to find the answer for all of the nodes. So you will take the help of your root node and will find the answer for its child. Then when you will get, again, you will now get the correct answer for your child. Now you will use this as the parent node and will find the correct answer of its child by using this exact same funda. That answer of child will be answer of parent minus the count of number of childrens in the child plus the remaining number of childrens in the parent end, which is n minus count of number of children in the child. Please make sure don't add the count of parent, because count of parent will store all these nodes. Count of parent will store all these nodes. And also it is possible that, okay, you might say, Aryan, I will say count of parent minus count of child. No, that will also not work, because what if the parent had one more parent? This parent might have one more parent. So what about that? So I have taken in consideration that, okay, apart from this node, all the other nodes are actually my other nodes, or basically the parent nodes, all the other different nodes. So that's the reason I have to add a n minus count of child. I cannot change that. I cannot say that count of parent minus count of child. All right. Okay. Cool. Things are sorted. Let's see the code. It's pretty simple. Now you see that how we went on gradually from finding n square and using that n square exact same algorithm in which I actually individually go on to a DFS, how to use that slight part to actually modify and use my children to get my answer, because I was earlier using my children to get the answer. Now to optimize it, I'm using my parent to get the children's answer, and that is the only optimization which is needed. So if I see the code, firstly I got my n globally. Why Rn this is needed? Because I just have few variables or few arrays globally, so as to use in all because I know I have to do a DFS call, simple traversal call. So I will simply have answer, which will store my final answer. Count will store the count of children's in the subtree. Graph is a like normal adjacency list. I will simply build my graph with the edges u and v. I have got the edges from u to v. I have got the edges. Now I have initialized my answer with the by default value of 0. Count is initialized by default with the value of 1, because I know every node is a subtree. Okay, even if any leaf node is there, it will have a count of 1. So by default, I initialize the count with a 1. Firstly, I did a DFS call. First, make sure the first DFS call is saying that I will make the use of my children to get the answer for me. I will make again use of my children to get the answer for me. And how I'm making the use of my children? I'm making the use of the children by taking their answer and by taking their count. So as to get my final answer, and this will only contain the answer for the root node. This, after performing this first DFS, this will only contain the correct answer for only the root node, which is 0, which you have passed in. So let's see how this function will look like. Again, make sure how the operations are built is operation are done while coming back from your child's, like, okay, you have got the answer from your child, from answers from your child, then you're coming back. So for the first DFS call, I went on to all the childs. Again, this is a tree, so visited is not required. You can simply compare. Again, it is a tree. It is the reason visited is not required. So you can simply compare with your child itself. Now you went on to your child. While coming back, again, as you can see, first I have a recursive call. Everything after recursive call is while coming back thing. So while coming back, firstly I updated the count of this subtree, the number of nodes in its subtree. Existing count was by default a 1. Although you can also transform this as saying count is equals to 1 plus count of their children. That is also you can do, but don't do it here itself, because initialize your count on the outside. Initialize the count of node by 1. Do here, not here. Else you will keep on adding 1 again and again. So you will get the count of your node. You will simply add the count of your children to get the count of the entire subtree rooted at node. Now you have to find the answer of your node. So answer of your child plus the count of your child will be the answer of your node. Again, make sure this answer is partial answer for all the nodes except from the root node. For the root node, this will be a correct answer. For all the other nodes, this answer is a temporary answer. That's it. Now I will actually start my another DFS call from my same root, which is 0. And now this time I will take the help from my root to compute the answer for my child. So while going down, I am actually finding the correct answer for my child. Remember what I am saying. While going down, I am. So like when I say while going down, which means that before calling the recursion, I will perform my operation, right? Which is while going down, not while coming back. This was done while coming back. This is while going down. So while I'm going down, I'll find the answer of my child will be nothing but answer of your existing parent, which is the root, which is the node. I will subtract the count of my child, add the remaining number of nodes. That will be the extra I have added, and ultimately I will get the correct count of my child. And I know I'm going down, 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 so I will be having the correct count of my child whenever. So I will be having the current count of my parent whenever I'm going downwards. Cool. And thus I can get the correct answer for all. Again, you can see I'm just overriding. I'm actually overriding here because I remembered that existing count, existing answer for all the other nodes were not correct. So it's the reason I have to override my answer. Cool. Ultimately, I will get my answer and I will simply return this answer vector. Time and space will be used O of n, and that's how I simply solve it. Now, I went on very deep into this because people just let you know that this is happening, but I wanted you to understand that at every point, how you are actually using your child, how you're actually making use of your parent when you realize that complexity will not work. If you liked it, please do like the video. It helps a lot. It motivates me a lot. It becomes very hectic to make everything with all these diagrams and stuff. And like I again make this because of I just wanted to make it easy for you guys to understand. Again, thank you for watching. If you have not joined the Discord channel, please go and join it. We do the contest discussions and also become live there. It is very easy to come live there. And yeah, bye bye. Take care. Bye bye.